Hi, good evening, everyone. Thank you for joining us in today's session. My name is Ankit, and I work as a data scientist at Analytics Vidya. For those of you who are joining us for the first time, Analytics Vidya is one of the largest communities of data scientists in India and across globe. Today, we are hosting a webinar on deep learning inference using OpenVINO Toolkit by Intel. The webinar will be presented by Mr. Prem Chandra Rao. Prem has over 16 plus years of experience in development of embedded software for mobile and multimedia system on chip. Currently working as Asia Pacific Japan staff lead for IoT and smart video. For last 8 years at Intel, he has been part of the Asia Pacific mobile tablet, real sense application enabling and emerging markets client enabling techniques. And most recently, he has been the engineering manager for IoT enabling team. So now I would request the audience to take a moment and participate in a poll. Right. So the first question was, which of the industry are you working for in deep learning? Of course, the others option has the highest number, but otherwise, if we talk about autonomous devices and machine vision, have a much more traction as compared to retail and digital security. And talking about the compute units, it seems like many people are still working with CPUs. So that was some interesting insight about our audience. So with these poll results, I would like to hand over the session to Mr. Prem. If you have any questions during the session, please type them into the Q&A section. Prem, the stage is all yours and you can start your presentation now.
Yeah, thank you, Ankit. Thanks for introduction and the poll. And yeah, hi all, good evening. Thanks for joining for this webinar. And today the topic is accelerate deep learning inference using OpenVINO Toolkit. As Ankit, introduced, I'm Prem Chandra Rao. I'm part of the video ISV enabling team, part of our developer relations division within Intel. And so my primary focus is to work with the developers and the independent software vendors to enable their solutions on Intel platforms. And this session is primarily, it has 3 parts. The first part would be more focused on the system overview, and the second part would be more focused on the OpenVINO Toolkit, and I try to do some of the demonstrations there. And the third part is that not just the inference, but other, what are the other, the pipeline part, and what are the tools we have. I would introduce that. So after completing each section, I would take a couple of, probably answer a couple of questions for a few minutes, and maybe I'll restrict you to a couple of common questions, and then move on. And probably end of the session, I'll spend more time in Q&A. And in this session, since OpenVINO is more from a open visual inference and neural network optimization toolkit, this is more focused on the image and video perspective. So this session primarily focus on tools and capabilities to video analytics developers, across the different domains. And the intention is that you'll be able to understand these tools, and you can go directly to the web links which are there present in my end of the session, and you can start using, post this my session. Okay, and with that, let's move on. As you all know, the Internet of Things is coming to life, and we see more and more parts of the physical parts getting smarter and connected to the internet. And so every device is seeing, how we can have some eyes and ears, and that's a kind of, the phase we are in. And about 15% or more things are connected, and it will be continue to be connected every year to the internet. And so the data these things are producing is growing exponentially, right? But are we really using it? Only small percent of the data is really being used. Report says that only 5 to 10% of the data is being actually used, and that too in a retro perspective. I mean that there's an incident happened, and you go back and check, and really it's not to do with something like a crime prevention. So if we want the system to respond in real time, we need to build a smarter automated system that can, probably automatically analyze all the data and take actions based on the insights. So I think, if you look at it, all the sensors, the camera is the ultimate sensor with so much of data being generated. 80% of the data is the video data on the internet. So we know, I mean, there's a lot of, work need to be done in this respect. So move on to build a, smarter automated system. So we probably, whenever, this is, as I mentioned, this is more of a system overview. So when we're talking about systems, we need to look at it more from a system of system, right? So we are not just looking at one sensor, or a one camera, which can monitor a traffic or a weather or, some of the surveillance, but we need to look at it, full system, hundreds and millions of cameras connected to hubs and connected to the clouds or connected, to big data analytics systems and, various other systems. So the really, big possibilities are coming, from analyzing the data, combining all these systems together. So that's a real key thing. And so in a system, in a city kind of environment, you have millions of cameras. I mean, at least, thousands of cameras being connected. So what just, not just the surveillance, but, there are many other things which you can do it. So moving to system of systems. And so what are those systems and what are the industries? And especially, being video being there and video cameras being there in most of the things, and doing analytics things is becoming a really, really important thing, because that can bring a lot of value. And so it could be in surveillance or automotive or industrial robots and many more. And each industry may have a, different devices with different capabilities and limitations. A camera, mounted to a car need to detect pedestrians, let's assume at 30 fps and 100 watt, whereas a surveillance camera might, probably do 10 fps and at 1 watt to operate. So there are few reasons why all of these new capabilities that look like as science fictions, but today these are all possible. The reason is there's a huge improvement in terms of the computational power, network bandwidth, and the other important aspect is the deep learning, because there's a huge amount of, improvements happened. And there's a lot of frameworks and, the public models, pre-trained models, and various data sets, that change a rapid growth in the space. And earlier, most of the vendors were doing on computer vision. Now, if you see it, most of them are doing on deep learning, and it's going pretty fast. And so what do we can do with these capabilities now, since, now, you know, without doing much work in terms of the development, you can, probably using a deep learning model, you can detect a car, and then, another deep learning model can help you to find a color of the car, and then you can detect the model of the car, and even license plate recognition number, and finally even the driver who is behind the wheel. These are all possible with a different, the deep learning models. And this is, reality, and this is happening in India. If you look at it, some of the smart city projects, or the traffic management solutions, no helmet detection, or 3 people riding on a bike, or no red light violation detections, these are all happening. And of course, it's not stopping there, and it's progressing well, and this is changing quite rapidly, right? So DL models are not just, only to analyze one frame, but across the frame, majorly to find the scenarios. The tracking is becoming really, really important. So in this example, we detect the people, as you can see on the left side, and we need to track them, just so that we know the vector of their movement, and then derive their intentions from their clothes or movement of behavior, and try to alert the store owner. The ones that are marked are can be potentially thieves, and these uses are different, but the good thing is the underlying algorithms and capabilities look alike. And so the challenges look similar, and of course, you know um, we can, of course, I mean, we can tune the algorithms to a specific case and a specific data set, but the basic operation remains same. So if you can do it in retail environment, you can do same thing in city environment, or the building environment. So more from a technical aspect, it's pretty much same. So how do we realize all these use cases? So you need some sort of hardware, right? So choosing the right hardware is important for specifically for really optimum usages. So these operations of computer vision and deep learning inferences are so compute intensive, and typically, accelerating them using a dedicated hardware is a must in some cases. But thing is that computer efficiency is a key, and it could be achieved at multiple levels, right? So if you look at it, CPUs has their own advantage. You have a lot of tools to compile, debug, analyze, and so more available for coding. But the performance for specific task, it might not be compete with a dedicated piece of hardware, but that was designed to accelerate more specifically for deep learning, like Google TPUs, or some of the dedicated hardware acceleration. You cannot compare, but there is a flexibility, and so there is a legacy infrastructure, those kind of use cases. It can be handled. GPUs are primarily designed for 3D rendering, but since that can do convolutions are more parallel, so this can run, deep learning can be run faster on GPUs as well. And other hand, when you move to a dedicated hardware, many times the problem is that the programming model is not known, and it is very difficult, and it requires a different expertise, and it's unique, and probably the scalability can be a challenge. So so we, as an Intel, we have CPU solutions, and we have integrated GPU solutions, and as you seen yesterday we have announced high density deep learning products, which has FPGA and which has a vision DSPs, which we call as a MoviDS. Okay, and I'll talk in my next couple of slides on that front. And the dedicated hardware also we are working. Okay, so one thing is, in some scenarios, it's not just a one specific compute we need to look at it. Probably we could look at it system, and see what are the compute units and how I can really fully utilize real heterogeneous machine. Okay, so maybe I can accelerate a DL, for example, on FPGA, and accelerate the encode on GPU, and do the rest on CPU. And so for to do this thing, what kind of tools I have, and okay, and do I need to code for specifically for CPU and GPU, and then so these are all really the questions, and today some of those parts is can be answered through OpenVINO Toolkit. So and so whenever we are kind of designing a system, especially in this thing, we need to look at it more from an edge to cloud perspective. And the first thing is the camera. And so probably if you look at it, camera, the people will primarily care about is the physical constraints, right? The power and size, and what is the cost, and performance efficiency, and latency for real-time use cases. And so these are all really important factor when choosing which is the best hardware for your camera. And the most common performance indicator is the performance for watt. Based on that, I think you'll be able to choose the right platform for this one. And similarly, the gateways and NVR. These devices, ingest and process multiple camera streams simultaneously, probably 8 to 100, and there's a strong media capabilities. And gradually we could do some of the the multi-channel inference we can do at this moment. And so mostly, hey, we have 8 cameras or 16 cameras. All of the cameras can be connected to hub and to one system to do that, and so that you could be able to pack more number of cameras with a single hardware, so that your performance per dollar or channel density will be higher. So that would be the key thing. If you're in a home, how many number of cameras and how much of hardware required. And if you're in building, okay, how many number of cameras, what is the hardware required. So that is what matters here. And when it comes to the data center and cloud, it's usually the less cost compared to other things, because seeking high density media DL throughput with flexibility to scale, and typically absolute performance throughput is pretty high in this case. Most of the times, a lot of things can be done on the cloud, but there are other advantage when we try to do more on the edge, where the data is getting generated and do the processing. So we'll talk on that front. So what are the offerings available from Intel for this one? If you look at it, you see we have CPUs, GPUs, and FPGA and MoviDS. And you can choose the Atom processor, probably operating at 6 watt. And there are other core platforms which is probably available from 10 watt to 40 watt. And Intel also offers an FPGA solutions with a varying amount of logic and memory from these segments. And even MovieDS, which has a great advantage having with one MovieDS core and two MovieDS core and 4 and 8, depends on your device. You'll be able to do it at a low power. That's a clear advantage which we see it. And similarly, a lot of NVR these days, I mean, if you see it, for especially the mid-end and high-end, are primarily mostly with a core-based platforms, and this gives a lot of the very efficiency in the media encoding and decoding, and so that kind of uh, gives us some amount of the flexibility. And and the second aspect is that yeah, probably more from a data center and cloud perspective, Xeon platforms are already kind of we have a leadership there, and we've been kind of using this processor by multiple cloud vendors, and even for doing inference, I think those are all really very very efficient. And so these are the kind of offerings we have. Okay, moving on. Yeah, so the designing a full network is very very important, right? So first of all, we want to understand what is the most efficient device to run on what is it a CPU or a GPU or FPGA? And second thing is that where we need to run this thing. If the camera itself capable to filtering out the non-interesting scenarios, then it can detect the real one and it can act fast, right? So without need to go to the cloud. So doing more analytics at the edge, and we can respond faster, and there is a more controllability, and there's a less bandwidth and less storage required for upstream. And so there's a lot of focus more on edge computing, and it saves a lot of bandwidth and storage. Okay, and in order to be able to simulate such a network, what we should do is we build a generic pipeline. And this is very very important, because any of the video analytics case, this end-to-end pipeline is the most important part. And the so we have a lot of information for the OpenVINO SDK. For this one, lot of sample apps are available. So but I just want to kind of give a quick uh, brief info on each of the stage. So let's look at the pipeline, right? First is the decode. And real systems usually use compressed video streams as input, so video has to be decoded, first processed. So this could be coming as a compressed image or compressed null stream, and then it has to be decoded. And the next one is, so typically we have a pretty good hardware accelerations, which we call as fixing. So for both decode and encode can be done using that. And the next stage is the pre-processing. Once you have your frame decoded, so you need to do pre-process, right? So according to your DL model resolution, you need to scale down, and you need to check whether the frame is ready to encode, whether the quality of the frame is good, and if there is any region of interest need to be found, so we can do that. And any frame reordering need to be done, we can do there on the pre-processing stage. And then we do infer, right? So inferencing is, we'll talk a little bit later, because that's the focus of the discussion today with OpenVINO. And the post-processing is that once you identify that whatever the objects of interest to you, once you identify, you need to write the bounding boxes on top of it, or you want to do some of the other drop the frame and you don't have a high confidence or something, you can do that, all that thing. So pre and post processing typically can be done using OpenCV. And then finally we have a encoder. Okay, if you want to do further analytics and you want to give the video stream for the next node or to the cloud, then you do the encode. Okay, so this is the pipeline which is very important. It's just not the inference. This end-to-end pipeline is very very important to realize the very efficient use cases on the video analytics perspective. Okay, and yeah, so Yeah, before I move on, I would like to see if I can take a couple of questions.
So I'll just dictate for a few of the questions.
Yeah, please. Yeah.
So yeah, one question is, can we use OpenVINO on Raspberry Pi with mounted camera?
Currently, OpenVINO is only supported for the Intel devices. Having said that, especially the MovieDS, which is the neural compute stick, which has been kind of supported for Raspberry Pi, and using NCS SDK, you could realize. But currently, most of the work is moving to OpenVINO.
Okay, so Abhijit asks, how efficiently does OpenVINO work with FPGA?
Yeah, so the FPGAs, we have a new product for FPGA. We have the deep learning accelerator cards, and as well as the new high density deep learning FPGA products we have. And currently, we have seen a very good performance with the FPGAs, and especially for real time inference, and especially for streaming and video kind of applications, FPGAs are more, because performance per watt benefit is pretty high there, and which can be alternative. So one of our biggest design wins from Microsoft using our FPGAs for their deep learning inference perspective, the brainwave project. That can be a great case study.
Okay, so one of the attendees, Phoenix, asks, can we run it on Ryzen CPU machines?
Yeah, as I mentioned, OpenVINO Toolkit is going to be open source, and once you have a open source, it can be really ported to various other platforms. Current support is limited to only the Intel CPUs and Intel platforms.
Okay, yes, one of the questions is by Keshav Bansal is, can't we use Google's TPUs and how does it compare? So that's his question.
Yeah, so in the market, of course, there are quite a bit of variety of offerings, and so Intel has always known for having providing a lot of scalable solutions. As I mentioned, one size doesn't fit all. So one particular SKU of GPU or TPU doesn't realize, because the number of different devices you have, from 1 watt to 200 watt devices, in between you have wide variety of the Internet of Things devices, and each of them requires a different set of capabilities. So that is why we believe in giving and more specific and optimized the edge devices, whether it is with CPUs or integrated GPUs or FPGAs and the VPUs, and doing a dedicated hardware accelerator can meet most of the real requirements. Yeah, of course, the TPUs can do well in particular segment, but as Intel, we are not just focusing on one particular segment. So we have a lot more scale, and we could meet most of the use cases what the current industries are looking at.
Okay, Prem, one last question and then we'll move on.
Sure.
So so Pradeepan Pal asks, why the DL training is limited to Intel CPU and integrated GPU?
Yeah, as I mentioned, currently the training aspect of it can be realized using our Xeon processors, and whereas so far yesterday we have launched the accelerator cards, and so now we could use both the MovieDS and FPGAs for doing the inference apart from CPU and integrated GPU, and typically the training is run on either on-premise server, bigger server farm, or on the cloud. Okay, typically it has been done, and the current offerings we have in that is the the Xeon scalable processor, and which could be used, and a couple of Xeon platforms has an integrated GPU that can be leveraged. So we would also provide additional hardware which are in work in progress, as and when it is available, we could use for that training. Currently, for intensive training, we have a couple of products working from Nirvana team.
Okay, yeah, that's it from the questions. So we can move on, Prem.
Yeah, sure. Thanks, Ankit. Thanks for the help. Yep. So let's move on. So as we have seen, little bit about the decode and encode, and which can be done efficiently using our, the quick sync and media SDK, and pre and post processing can be, you know, uh, done using CV SDK. So what about inference? And this is, the real thing. I think, as one of the attendee asked, what are the issues in, I think, DL inference, um, because typically the training is more of offline activity, and you can spend as much as time, some in some cases it could be days, in some cases it could be weeks to do the training. And it typically this is not a kind of production deployment environment. So, and there's a lot of data, especially the some of the dropout layers and couple of things which are not really needed for inference. Those components are present. And um, and hardware requirements are quite different. Training is different, right? You can do it on server farms or on the cloud, whereas when you're doing actual edge deployment on a retail store or in a city, surveillance on a smart pole, or anywhere. So the power consumption becomes critical. So you need to make sure that it is really optimized for the performance, memory, and the cost. That's very, very important. And sometimes the performance goals are different. Typically the training is done with a large batch size, and whereas inference is done with a typically with a fewer number of frames. And so what we can these open source things can also bring in a lot of issues in terms of the production readiness. And using these frameworks, we will be able to do a lot of time to market can be improved really. And the deployments has become a lot more easy. And so this is what we focused, and that's why we have introduced the toolkit called the OpenVINO to address this problem specifically. So what does OpenVINO toolkit has is, currently it has support for, this is more focused on the inference. Means, we assume that you have done the training and you have a trained model, which you have, used some public models, which are available in TensorFlow or Caffe GitHubs. You retrain the models according to with your data sets. And you have those models. For example, in Caffe, you have a .Caffe model or prototext that you give it to model optimizer. The model optimizer would typically do some magic and convert into a specific intermediate representation format called as a XML and bin file. And those models would be feeded to inference engine. So the good thing is that here inference engine is with a single API you would be run your model seamlessly across CPU, GPU, FPGA, VPU without any change. So by just changing the command line, you'd be able to run across all this, the compute unit. So that's a key thing. And of course, as I mentioned, the OpenCV is a pre-compiled version of OpenCV 3.3, and it has a full Intel CPU optimization to it. And we have also added a new Intel photography vision library with face detection and vision, and blink detection and smile detection. These are all the additional features we have added, and it's more robust and stable. And OpenVX is a graph-based implementation for the traditional CV operations, and with the CNN primitives. And it supports OpenVX version 1.2. And we also have a WAD, which is a designer which you can easily create a use case. And of course, as I mentioned, we have a media SDK, which is primarily to decode and encode and post-processing functions to be done very efficiently on Intel platforms. The OpenCL aids to do and efficiently use the GPU. And we also has a FPGA runtime as part of this to aid FPGAs running seamlessly with OpenVINO. So this is all comprises the OpenVINO toolkit. Okay, moving on. So what is the benefit of using OpenVINO is that if you're directly running any framework, directly you do the git clone of your framework and directly like Caffe or TensorFlow and try to run a model, it'll run very slow. Whereas if you use this OpenVINO toolkit, the performance, compared to the standard uh, baseline Cafe or TensorFlow, the performance is, at least 4 to 5 times would be improved. And we have profiled and we support a lot of public models, and most of the documentation is available on the web. And so you could see, what are the models are supported, and and you'd be able to run this model seamlessly on your hardware, whether it is CPU or integrated GPU or other hardware if you have. And so yeah, and of course, you have options to change some of the data formats and quantization, and that can further improve the performance. Okay. And apart from providing improvement in the performance, and giving more one single unified API to do and run on each of the compute unit device. And we also have a lot of pre-trained models available. uh, if you look at in retail environment, emotion detection or age, gender, or face detection or face recognition, license plate recognition, and some of the smart classroom analytics like head pose, and more from a transport perspective or autonomous driving perspective, person and vehicle, and various detections. All of these models are available and which are optimized for Intel platform, and which you can directly leverage and build on top of it. So this is one of the advantage if you are just starting on a deep learning, and you can take these models and run, and there are plenty of examples and sample apps available in the OpenVINO toolkit. And now with that, we would go a little bit and more deep into the OpenVINO. And so as I mentioned, the first thing is the training. So training is done typically in offline, and then we would need to do prepare and optimize. That is where we use the model optimizer. And this would take, as I mentioned, the prototext and Cafe model and give you the intermediate representation format called as a XML and bin file. And then you would need to do the inference. So we have a sample applications provided for inference engine. And so you would be able to use and run these models. And so once you run, and depends on the command application you use, whether it is you're targeted for CPU, GPU, or VPU and FPGA, the respective plugins would be kicked in, and and it will automatically run. So you don't need to do any further integration or work. And so if you have selected -D CPU, then it will run using mkldnn plugin, and it will run seamlessly. And when you select -D GPU, it will use CLDNN and it will run. So DLA and Mirai, all of them you would run. And some cases when you have a systems and you wanted to really take advantage, if you have a system, typically most of the CPU will have a GPU as well, right? So integrated GPU. So when you use hetero, you would be able to use both CPU and GPU. Some of the layers can be run on CPU, and some of the layers can be run on CPU. And of course you can do a fallback also. When you have a higher performing hardware, the FPGA can be a primary option. And then if some particular layer is not supported in FPGA, it can fall back to either CPU or GPU, and those can be run. And you always do some amount of your own customization in the neural network topology. Even those can be supported as part of the extensions. These are all pretty much taken care, and a lot of the video analytics vendors are adapting this toolkit. And so moving forward a little bit, I wanted to show you a glimpse of how different things run. And so first thing is, you could model downloader. So you can just download the public models which are available, because there are multiple models either from TensorFlow or Cafe, and which you can download. And as well, as I mentioned, Intel also has a couple of video analytics part of the OpenVINO toolkit. And so what I'm doing here is that I'm using a one downloader script, and I'm trying to download a model called SqueezeNet. Okay, and this is like to do the basic image classification. So once you do that, so okay, and so your model is downloaded now. Okay, so So you see there is a proto text file and there is a cafe model available now. Both of them downloaded. Now let's do the model optimizer, right? Which would do the conversion. And some cases, what happens is the CPU, we can support FP32 as well as FP16. For GPUs, we support FP, 16 only. And for Mirai, we can support, FP16 as well. And in that case, some of the conversions can happen. And if you want to do quantization, it can happen. And some of the optimizations, as I said, node merging or fusing of the layers, and a couple of them can be done by model optimizer. So yeah, and this is what I was talking about. And can I add scaling normalization, cut some drop. And so now what we will do is, so we use mo.py, which is model optimizer, which is a Python script, and we would give input model as a squeezenet and data type as fp16, and defaultly we are not giving any input parameter. It means that defaultly it is running on CPU. Okay. Okay. Yeah, so now what do we do is, so now you see when you run model optimizer, there are two files which are generated. One is the XML and bin file, as you see here in the bottom two lines, the bin file and the XML file. Yeah, this is very important. So if typically most of the models, public models, we support it, and so it will seamlessly work. And if there is a model which you have a custom layer, so there's some work need to be done here to add that custom layer. So we have a detailed documentation on the website which you can follow to do that. Okay. And moving on, so the next step is, since we have converted the model, and now we move on to do the inferencing part. So as I mentioned, so this is a very simple 3 APIs we have to do the inference engine, which is pretty much like your OpenCV DNN. And and we kind of quicken each of the plugin as per your selection of the target hardware, whether it is the CPU, GPU, FPGA, or BPU. And so what I'm doing is, here I have a sample application called tutorial. So the first one, so when we run this, what you see is that the pre-processing is 8.4 milliseconds, and post stage is 1.77 milliseconds, and inference is taking about 32 milliseconds. So the inferencing is taking more time. So this is how we can convert how much is the APS, and so how many number of frames is happening, we can check it up. And so we can improve, there are certain ways we can improve this performance. So we will see that how to do that. Okay, so this is the batch one we have given. So we'll take some other model, which is object detection model, which is SSD GoogleNet. And what I'm trying to do is, here I'm trying to run with a GPU. So what I'm just changing here, you notice, is that instead of minus D CPU, here I'm giving a minus D GPU. I'm not changing anything else, and you'll be able to run your model seamlessly. And so here is a model which we are given and running as a minus D GPU. And okay, and you see here the inference time is reduced, right? 20 frames milliseconds per frame. So we almost got like APS as a 47 here. Okay, and similarly we can do increase the batch size. And okay, so what I'm doing is, here I'm increasing the batch size as a minus batch 16. So we will see how this will affect the inference performance on the GPU. Okay, so when I'm giving minus 16, you see the inference time is 12.12 28 milliseconds per frame. So this is pretty good boost, almost like the frames per second is like went up to 83. So what you can do is, always you can validate your model which is converted, first run on CPU as an experiment, how much is APS, and then run on GPU, or if you have other hardware you can check it up and see which is giving you the best model. Because what we have seen is that if some of the models run better on GPU, some of the models run better on GPU. And so So you could use it, and some cases you can use both both CPU and GPU in asynchronous mode, and and so you would get more better performance, and you can offload certain models to the compute units accordingly. Okay, and the other hardware, as I mentioned, MobiDS. Currently, we have commercially the neural compute stick is available, which you can procure, and so of course, we have launched the high density deep learning VPU based cards. So now those would be having like 8 MobiDS on a single mini PCI card. Those would be available, and would be good alternative for many of the other platforms. And so what you need to do here is that you just need to mention -d Miride. Okay, you don't need to earlier we have used -d CPU, -d GPU. Here we need to use -d Miride for the same model and the same application. I have not changed anything here. So when you do it, and the other operation, as I mentioned, we can use the hetero plugin. So hetero plugin is, we could uh, uh, we could use both GPU and CPU. Here is the GPU is the primary, the option, and if some model is not supported and some layer need to be offloaded, we can offload to CPU. So that for both in a system where you have multiple compute units, you can use the hetero plugin and take advantage of it, so that you have a more better performance. We have a complete workshop content which is available openly on the GitHub as a smart video workshop. You can download, and all this exercise can be done. This is being done from there. So post this session, I can probably provide you the link for the same. Okay. Yeah. So yeah, so as I mentioned, extensions also available if you add a custom layer in your the fully connected layer or later on. So you could add both on the model optimizer side, and the respective kernel also need to be added on the inference side. So that's how you can extend it. Yeah. So Ankit, since this is one last section I have. Before that, I just want to take a couple of questions.
Yeah, so Prem, you can access the questions from the Q&A section now. So people have posted there.
Okay, cool. Thank you.
Can you see the questions now?
Yes, I can see it. Thank you.
Oh, great.
Okay, why the DL training is limited to Intel CPU and integrated GPU? I think, and I have answered this. Can this run on I series processor only, an Atom or Celeron Xen series, or also does it require to have opt-in drive? It will be run computational. I think Keshav Bansal has asked, can this OpenVINO run on I series process only, an Atom, Celeron, Xeon series? Also, does it require to have the opt-in drive to be operational? I think no. I think there's no requirement of the storage. I think we have a clear the hardware requirements, specifications on the OpenVINO when you download it. Typically for Atom we have Apollo Lake N series, and which are Celeron platforms, and all core i3, i5, i7 platforms are supported, and Xeon also being supported, and the all mostly from 4th generation onwards, sorry, 6th generation onwards. And Enemy MEG is asked a question: when we are converting a trade model using model optimizer, can we expect any change in the accuracy as we are separating the network structure from the bin file? Currently, as far as if we are maintaining the same data format like FP32, okay, there won't be any accuracy changes, because we are not doing anything. What we are doing in the model optimizer is we are just trying to fuse the layers, so that we're doing a pre-computation. So instead of doing in a multiple steps, we are trying to do in a single step, so which can avoid the memory read and write, so the performance will be better. Apart from that, with the data accuracy, we are not doing anything unless you choose a quantization or a change the data format from AP30 to AP16. Then there can be accuracy loss. Otherwise, typically we have seen from AP32 to AP16 also, we didn't see much accuracy loss, but there can be in some certain cases. And Abhijit asked a question: as regards GPU, with respect to Intel integrated GPU, are consumer grade CPUs powerful than enough to run? Yes, absolutely. All the content as an OpenVINO toolkit seamlessly you would be able to install you on in your the the laptop or desktop which you are using as a, and you will be able to run the entire workshop content, and it can give you a pretty good decent performance. And yeah, Intel Raghava Reddy is asked a question. OpenVINO Toolkit work only on Intel server? Yeah, it can work on all Intel platforms, as I mentioned. I attempt to go to Xeon platforms. And Parthipan Pala asked a question. Can OpenVINO training run on Intel CPUs and NVIDIA GPUs together? The performance comparison would have been more meaningful. Yes, we do have the comparison information. If you probably contact me, I can share that information on the front. And currently, the OpenVINO toolkit is more focused on the inference, not on training. And so you know so that is why we have given a couple of the DL models, and which we kind of showcased. And of course, obviously, if you're really interested to know how we perform against the GPUs, I can share that information. Our Anand asked a question: Are RNN operations supported by OpenVINO? Example: LSTM cells. Currently, we don't have support for RNN. Especially, this is more focused on the visual side. CNNs are more friendly and currently being supported. RNNs and LSTMs are in work in progress. Okay, I think probably in R4 release, currently we have R3, but R5 release will have some amount of support. We have one specific framework called CALD, which is supported now. And yes, Anand asked one more question, that does conversion AP16 lead to accuracy loss? Yes. Okay, and one last question, probably I'll take it and continue, and then I will cover the rest of the questions. I think how many questions more I have here. They're quite a bit. Okay. Vijay Krishnan, can we use OpenIntelliJ for speech recognition? Is there any plan for supporting PyTorch? Yeah, PyTorch has been asked, and speech recognition, as I mentioned, CALD is the one framework which is supported. Yeah, so in future, as we have a strong request, yeah, we can probably support, I think, with RNN and LSTM support, the speech recognition will be better in OpenVINO. Okay. Yeah, so one last question is Praveen, when is support for S10 is expected to be available in OpenVINO? Any solutions available for Stratus 10? Yes. So ARIA 10 is currently supported, which is available as a HDLF card, which is available from IEI, a particular ODM as a Mustang with a QNAP. So if interested, I think these are all available, and which we could help to seed you or provide access from our lab, or you could directly purchase also. Okay, and I will probably answer other questions later, after completing my presentation. Ankit, is it okay?
Fine. Yeah, go on.
Yeah, thank you all. Okay. Yeah, so since since we talked about inference and OpenVINO, how it can not just kind of give you the performance improvement, in terms of the memory, power, and the performance aspect of it, but it also gives you stability, and which is more production, and you can do the time to market improvement. And as well as this is a single unified framework which you can run efficiently on all the compute units, which is CPU, integrated GPU, FPGA, BPU, and future any other hardware. And that is one of the biggest advantage. Okay, so when we do that, as I mentioned, it's not just the one inference, even other components are important. So I just briefly touch upon, and we'll conclude this webinar. So OpenCV is one of the very popular open source project which has been kind of being used by multiple vendors, especially in the computer vision. And so OpenCL is being used as one of the direct coding language, and so we have this being integrated, and it is very well optimized, and it can give you a lot of performance boost, and when you use the integrated OpenCV, which is available in OpenVINO. Okay, and one of the important thing which we have discovered is that even though a lot of vendors using the code based platform, but they are not fully leveraging the entire power of the the core based platforms, because that has a good amount of silicon die, um, which comprises the GPUs. So when we show our benchmarks, and we kind of show them that this model can give this much FPS and unintegrated GPU. So a lot of vendors are trying to make use of GPU, and so even some in cases they don't even need additional GPU, and which they can fully use the full capability of the hardware platform. So this is being very very important aspect to talk more about integrated GPU and show the various benchmarks of the models only run on the GPU. And so we have seen in some cases it's a lot of models are running better on even on in some cases it's running better than CPU and GPU. So when you use combine both the things, it's really really coming out well for a lot of partners. And so with OpenVINO, that has become a lot more easy for a lot of partners. And we have currently integrated. So we have, as an Intel, if we look at it, we spend quite a bit of resources and money on this integrated GPU, because every processor will have almost 50% of die, and it's very very important to fully utilize this the hardware. Otherwise you're not fully making use of, and your investments are not really optimum. And so for GPU can be really very well utilized for both three stages, for both decode and encode and pre-processing purposes. And three types of GPUs we have: GT2, GT3, and GT4. And you have a use accordingly 24 to 48 to 72. And we also have a specific the fixed function hardwares like multi-format codec and video quality engine and scalars. This would do a dedicated the video encode and decode and post processing functions, and whereas the use are free to completely to do your inferencing. So there is no absolute issue while doing decoding, and multiple parallel streams are being decoded or encoded at the same time. You can do inference using GPU without the our OpenVINO interface. Okay. Yeah, so as I mentioned, this is the VD box, which is fixed function box. These are all can be directly uh, mm, interfaced with the OpenCL, but using media SDK. But now we have simplified completely abstracted out through OpenVINO, so directly you would be able to take advantage of this um, hardware units. Okay, one last thing is the media SDK. As I mentioned, we don't want the developers to go and talk to the low-level libraries. So we have given a high-level SDK, and which is a media SDK, which is now part of OpenVINO, and this would support a lot of codec formats to MPEG 2 to H.264 to latest H.265, and in whatever level or profile are supported. And you can do a lot of post BPP, which is post processing functions, which you can do like resize as well as the color scaling and color conversions and denoise and various other aspects. This can be realized, and we have multiple the kernels written in OpenCL, which can run very very efficiently. And this is a completely free SDK, and if you're using on a Core or Xeon E3 platform, this is going to give you a lot of benefit and more number of can be channels when you try to use the quick sync through media SDK. Okay, and so moving on, one other tool also being integrated into the OpenVINO is the System Studio. As I mentioned, when you have a lot of system like CPU, GPU, and integrated GPU and various things, how do you want to really analyze the entire system, that if there's a bottleneck, and hey, when we show the benchmarks, this is the number of frames per second, but when I'm running on my system I'm not getting. But how do I really identify the bottlenecks? This is a tool which can kind of give you a complete analysis on how your how various layers are running on what. So for example, here I'm running in a SSD Google Net on GPU with 4 frames, and you see, and you see how this different frames are loaded, and why this there's a huge time taken by the loading the model because of the compiler, and then how the 4 frames are processed. This can be, even we can go deep and do profile and understand which are the functions taking more time, and we can specifically see how we can optimize those functions on the front end. Even we can go much more level to fine granularity level of your neural network layer, each layer, like convolution to batch normalization to pooling to various things. We would be able to really examine using this tool and see on what it is running. So this is really pretty important tool when you want to really optimize for performance and power. This would be very, very handy. So as I mentioned, OpenVINO is primarily for inference, and Media SDK is for decode and encode and post-processing. And for pre and post-processing, you can use a lot of OpenCV, which is optimized for OpenCL. And Intel System Studio is primarily to do entire analysis of the system if there's any bottlenecks anywhere in the system. Okay. So with that, I would like to conclude that when we are kind of looking at any particular use case, whether it is a computer vision or a deep learning or media, and you should look at it entire software stack, full stack for your use cases. What is it offering available from Intel? What are the different libraries? What are the various tools you have for development, the tool chain part, and what are the SDKs? And we also are giving a lot of models and the sample applications and some of the reference implementation, which can ease out whether you're working on a retail or autonomous driving or drones or robotics. We have a lot of samples, and which you would be able to do some of the basic stuff like face recognition or gender detection or object detections and classifications. All those can be done very, very easily and very efficiently. And you should look at it more from an end-to-end pipeline, and and don't leave out any of your compute power, and you should make use of every transistor which is available, so that your solution become a lot more optimized, and so that you can be in a your solution can be you know nobody can beat your solution. So yeah. And so yeah, so how do we get it and to start working on? Here is the link. The OpenVINO SDK is the, I think when you type, and you would get these links in the beginning in your search engine. And so there's a lot of smart video portal, and when you type Intel smart video workshop, you have the complete workshop content, and we do workshops. And we do organize some of the the meetups, so you could feel free to join to learn more about our tools. So with that, I will just conclude and probably take answer the remaining questions. And yeah.
Yeah, all the attendees, this is a good time to ask any question that has been occupying your mind. There are already some questions. So Prem, there are already some questions at Q&A, if you can check.
Sure, I'll do that.
Yeah.
Yeah, so I think
You've answered.
yeah, yes, I have answered till Praveen question. And
Okay.
Anai Maji asked a question. Suppose I'm using a custom model having non-supported layers, example RN and LSTM. Can we use the offload unsupported layer to TensorFlow Cafe to accommodate the layer? If yes, can you please explain how? Yes. So as I mentioned, one thing is that whether you can, if a function particularly which is not supported, you can add that function as a custom layer. We have provisioned some in our framework, and which you can add that in our model optimizer. And same the C++ code which you have for that custom layer as a kernel need to be added to the inference engine. But still, if you want to directly offload, you need to install your entire framework on the edge device where you're doing inference, and you would be able to directly call the framework. Okay. And still, some of the layers which are optimized would run using the OpenVINO optimized libraries, and the performance will be better. And yeah, other question is Ashish Kejriwal on Raspberry Pi with the NCS USB stick, can OpenVINO Toolkit be installed? Has somebody who's tried out? Yes, there are many people tried out, and I think as I mentioned, till 2 months back, we've been supporting NCS SDK, and which has been, currently we have integrated parts into OpenVINO. So now OpenVINO can support, and so just type NCS, MoviDS, and OpenVINO. You find a lot of the information there. So we have seen, particularly we have run also some of the workshop content. And the next question is, could we have a benchmark for MoviDS sticks? Yes, yeah. So currently, which is not public, but certainly, yeah, we could share. And we have a couple of, the models which are running on MoviDS, and in our workshop content, when you type in Google Intel Smart Video Workshop, you would be able to, find a couple of exercises to do on MoviDS. And we have seen a, MoviDS currently it's Mirai 2 basis. It's not so, because it's a sub 1 watt platform, it is not very computationally intensive platform. So it might give you a lesser performance, but it is, pretty useful for some of the, low power, like wearable devices or drone devices and couple of things. This is, really, really useful. Okay. And yeah, for some of the smart helmet kind of use cases. Okay.
Okay. So Prem, there is one question at the chat section. So which is, can we use OpenVINO Toolkit for speech recognition?
Yeah. Yeah, as I mentioned, currently we have supported one framework called Scaldi, which is supported. But if your speech really depends on RNNs and LSTM, currently we don't have much support. As OpenVINO, as I mentioned, is more on a visual inference perspective, so more focused on the CNN, which is convolution neural networks. Okay, so as we more progress on this, we would definitely support more on speech DL models. Okay, and you could just try it out and let us know. As we open source OpenVINO, you would be able to directly work on that. And if you have any questions, please feel free to reach out through our forum, which is computer vision, Intel Computer Vision forum. Our experts would be help to answer your queries.
Okay, I think we are done with the questions. So I request the attendees to ask. So we still have time, and you can ask any question if it comes to your mind. Okay, I guess there are not any more questions. So yeah, so thanks a lot, Prem, for taking your time out for this wonderful session. The OpenVINO Toolkit certainly looks like a product that will enable a lot of practitioners to develop a multitude of computer vision applications. Especially the inference part, which not many people talk about. So that was really interesting in this particular webinar. Before we close, we'll take a moment to we'll ask the attendees to participate in a final poll. So I'll just launch the poll now. So this is a poll for feedback. So this will really help us to put the best content out there for our community. So yeah, I request the attendees to please answer both the polls. Okay, I'm ending the poll now. Okay, all right. So thank you, Prem, and I thank the audience as well for with this wonderful interaction that we had. So I just want to inform everybody that a recording of this session would be available on our YouTube channel in case you want to revisit any section from the broadcast. Also, a small exciting update from Analytics Vidya. So we'll be hosting the India's most advanced conference called the Data Hack Summit 2018 with Intel as our platinum sponsor in Bangalore. So this would be from 22nd November to 24th. This would be a 3-day conference which will have multiple workshops, hack sessions, power speakers, and make sure you check it out right away at the Analytics Vidya website. So, so with that, I take your leave.
Prem, thank you. Yeah, thank you, Ankit. Thanks for your support. Thank you all, for joining. I know it's pretty late, but yeah, thanks for joining. And as Ankit mentioned, yeah, please revisit. And if anything is there, please feel to reach out to Intel team or to me specifically. I'll be able to, specifically address if you have any, support requests. Yeah. Thank you all. Yeah.
Yeah.
Thanks, Ankit. Have a good day.
Thanks.